Oh, welcome to our second video looking at water cycle for year 12-13. What I want to do is get you started straight away. Have a look at this diagram. Stop the video in a second and see, can you work out what the missing boxes are? So stop the video, give yourself 10 seconds, 20 seconds, how long it takes. You should have this diagram on the sheet I've emailed you with worksheets, and have a go at seeing what the missing labels are. Okay, so let's see how you've done. So this is a bit different from the one we were looking at. This is a hydrological cycle from a river basin rather than the whole global hydrological cycle. So the first thing that's different here is it's got inputs, and that the key input, in fact pretty much the only input, is precipitation. Even if you've got snow melt in the river basin, because you've got glacier or something melting, that glacier got its snow, its ice, from precipitation. Remember, precipitation is more than just rain. So you've got precipitation, okay, that'll get intercepted by the trees. The water will then sort of trickle down the stems or whatever, and then when you think of it, it's going to end up on the surface. And if you notice, that's a slightly green colour, so that's a store. So basically what we're talking about on the surface is puddles, and what we call surface storage. Now, that surface storage will then either, one of two things will happen to it. It'll either, three things, sorry. It'll either run off, overland flow, go into the river and eventually disappear, or it can soak into the soil. And if it's soaking into the soil, well, we call that infiltration. And that's a really important concept that you need to get your head around. This idea that water will, at different rates, go into the soil from the surface, and how quickly that happens will have a massive impact later on when we talk about floods. Now, once it's in the soil, it can then either go further into the ground through percolation, or it can go through the soil, okay, into the river. And because geographers are unimaginative, we call that through flow. And the other possibility, which rather than going off into the river, is it goes back up into the atmosphere. And again, because this isn't a closed system, it's an open system, that's an output. So we've got an output here of evaporation. And that's the key difference between the global hydrological cycle and this diagram. The global hydrological cycle was a closed system. There were no inputs, no outputs. It looked at the water couldn't escape. Here, we've got water exiting through transpiration, evaporation, and runoff. And we've got water entering through precipitation. So this is very much an open system. And this is what we're going to look at today. So let's have a look. What we're going to look at to start thinking today is the processes that affect a drainage basin. And we're going to know what those processes are. And we're going to start to think about how physical factors affect them and how human factors affect them. Now, before we start going into physical and human factors, it's important about just visualizing what we're talking about. We're not talking about a system. There is a cycle. There's water flowing around, but importantly, it's open. Now, what I want to do is give yourself 30 seconds, stop the video when I finish talking, and just look at this diagram, see how much you can remember, because in a second, I'm going to ask you to write down how many inputs, how many flows, and how many outputs you can remember. So stop the video. When you think you've got it, let's have a look and see. Okay, so now what I want to do is draw up a table that looks like this. So inputs, flows, remember flows can also be known as fluxes, and outputs, and put down how many you can. When you've got it, okay, I'll stop talking in a second, and when you've got it, press play and we'll see whether we've got the same list. Okay, so let's get started. So inputs, really easy. There is only one input, and that's precipitation. Even if the water in a river has come from a glacier or from snow melt, it's still originated in that drainage basin as precipitation. So that's nice and easy. And one of the things we'll look at the different types of precipitation, but we'll do that in a bit. Now flows, there's a lot more of them, and you do need to know these. So you need to know about interception, okay, which is the trees and the plants catching the rain. Infiltration, which is equally, perhaps more important, which is the water soaking in from the soil, or from above the soil, sorry, into the soil. Saturated overland flow is a bit different from overland flow. It's basically where the water table reaches the surface and starts to move. We'll look at that in a second in the next task I'm going to ask you to do. Overland flow or surface runoff, again, water flowing over the surface, through flow when it's going through the soil, percolation when it's going from the soil into the bedrock underneath, groundwater flows when it's flowing through that bedrock, and channel flows when it's flowing through the river. And then finally outputs, and again there's much fewer outputs than there are flows. You've got evaporation, transpiration, which we often put together to call evapotranspiration, and you've got the river runoff, you've got the river flowing out into the sea. Now what you need to do is you need to be an expert on all of these terms. Now if you look at the PowerPoint I've sent you, it's got some information sheets. Your job is print those off or whatever you want to do with them, have a look at them, but you need to have detailed notes on each of those different flows, inputs and outputs. Okay, so that's your job. So I'd stop this, have a good look at that information, probably a 20-30 minute job, get that done and then press play. Okay, now one thing that we do need to look at are the different types of precipitation. Okay, and precipitation is any form of water, whether it be ice or whether it be liquid, that falls from the sky due to gravity. Now, that makes perfect sense, but there are three different types of precipitation you need to know. So the first type is what is called orographic, or, okay, a slightly more common name is relief rainfall. And what I'm going to do is I'm going to talk through the type of rain, and then you have a choice. You need to copy the diagram or a version of the diagram, and then either print out the sort of missing word activity and fill it in, or even better, in your own words, put it as a list of statements. And when we've done this with the three, I want you to think about what they all have in common. So with relief rainfall, what you have is you have a prevailing wind, and that prevailing wind is taking warm moist air off the sea, and it is then basically hitting a mountain or a hill range. Where it hits the mountain, it's forced to rise. As air rises, it will get colder. It's about 0.6 to 1 degree per 100 meters. So if you work on 1 degree per 100 meters, something like Everest, which is what, 5 kilometers high, is 50 degrees colder at the top than it would be at sea level. So as the air rises, it gets colder. And the way to remember that, because it's a little counterintuitive, most people, when they think about it, we're getting near the sun, so it should be getting warmer. But think where the snow on a mountain is. The snow on the mountain is on the top, and that's because the top of the mountain is colder than the base. So as the air rises, it gets colder. As it gets colder, it will condense. It will condense to form clouds, and then eventually, if that gets colder still, those water particles get too heavy, and it precipitates. It rains. And what you'll notice is that nearly all of the rain is actually on what we call the windward slope of the mountain, the side facing the wind. And that's because as soon as the cloud gets to this side, it starts going down. And when the air is sinking, it's getting warmer. And that means that actually the air can hold more water, so there's less likelihood of it actually raining. You might just get a tiny little bit, what's called spillover, just on this side here. But this side is where you're going to get very little rain, and we call that a rain shadow. And the classic example would be Britain. If you think about where the mountains are in Wales and up north in Cumbria and whatever, the Pennines, basically what you find is that all the rain, or most of the rain, forms on the west of those mountains, and where we are on the east of those mountains, it's much drier. So that's the first type of rainfall, and like I said, it's called orographic or relief rainfall. Oro, I think, is just Greek for mountains or hills, which is where it gets its name from. Now, the next type of rain is the reason why we get rain even in the southeast of England, and this is frontal rain. And basically, frontal rain happens when you have two air masses, giant areas, could be 1,000 kilometers across, of air meeting. And in particular, what happens is you have warm air, and your warm air on this side, meeting cold air on this side. Now, sometimes it's the warm air going above the cold air, and when it's the warm air rising over the cold air, we call that a warm front. And sometimes it's the cold air burrowing underneath the warm air. And when that happens, we call that a cold front. But either way, the same basic principle is happening. Okay, warm air is hitting the cold air. Cold air is heavy, it's dense, it's going to stay close to the ground. Warm air is less dense, it's lighter. So when the two meet, the light, warm, less dense air is forced to rise. As the air rises, it will condensate because it's getting colder. It will condensate because not only is it getting colder as it's going up higher, but it's also it's in direct contact with cold air. So that tends to form clouds. And in fact, it forms very layered clouds, okay, called stratus clouds. And that again, assuming that the air is cold enough and there's enough condensation, eventually leads to rain. And it tends to gentle, persistent rain. So that's the second type. Now you often get these in weather systems called depressions. And normally what happens is you get a warm front followed by a cold front. And because of that, and because that sort of system is sometimes known as a cyclonic system, it's sometimes known as cyclonic rainfall. But, so most commonly known as frontal rainfall. And then the final type of rain that you need to know is what's called convectional rain. And convectional rain, in many ways, is the simplest. And again, this diagram shows it quite nicely. You've got the sun heats the ground gets hot, the ground heats the air next to the ground, that air gets warmer, expands. We know warm air is less dense, so that therefore will rise. The air rises, as it cools, it condenses, it forms clouds. Now, this is something which is the most important form of rainfall in, say, places like the Amazon, where it's very hot, you're on the equator, you've got huge amounts of solar radiation. In Britain, it's probably the most important way of causing thunderstorms, particularly in the summer. So when you've got a hot, humid day and you can start to see the clouds bubbling up, that's convectional rainfall, convectional precipitation. So they're the three types of rain. Your job is to make sure you've got a diagram of each and you've explained each in your own words or using the missing word activities. But the question I want you to think about now, once you've got that done, is what they all have in common. If you had to boil down those three types of rainfall into one common theme, what is it? Just look at your diagrams and see. And hopefully what you can see is that the one thing they've got in common is that air is rising. It rains when moist air rises, cools, condenses, and precipitates. That's what's going on. All that's changing in the three types of rainfall is the mechanism by which the air is being forced to rise. The basic principle is the same. Warm, moist air rises, cools, condenses, precipitates. Okay, so that's basically our types of precipitation. Okay, now that's going to have a major impact on the input going into it. The amount of rain, how heavy the rain is, the intensity of the rain, that's going to be controlled by the type of precipitation. Next, what we need to look at is other factors that are going to affect those cycles in a drainage basin. So just have a look for a second. What can you actually see here? Okay, well, what I can see is over here, we've got the geology, we've got the rock, whether it's permeable or impermeable. We've got the climate, which we've kind of already covered. But notice it's not just rainfall, it also includes a temperature, because that's going to control the amount of evapotranspiration there is. And also, to be honest, it'll control the amount of vegetation and other things. And that leads us on to this one, which is vegetation. We've got the soil. That'll be the permeability, the porosity, basically the type, and lastly the relief. Okay, how flat or how steep the land is. So all of these factors are going to control the processes going on in a drainage basin. So your next job is using those 5 factors. Can you match them up against the definitions on your worksheet? So again, stop the video. If you haven't printed off the worksheet to go with this, please do that. Have a go and see if you can match up those 5. And when you're ready, press play. Okay, so let's go through them. So has a role in influencing the type and amount of precipitation overall, the amount of evaporation, okay, and the vegetation type. Well, if we're talking about precipitation, if we're talking about temperature, we really must be talking about climate here. Then we've got determining the amount of infiltration, through flow, and the vegetation. Well, we know that free flow is water flowing through the soil, and that makes sense. We know infiltration is the rate at which water goes into the soil. So that second one is going to be soil. Can impact subsurface processes such as percolation and groundwater flow. Well, we know that's ground rock, water in the rock, sorry. So that's got to be the geology. We also know the amount of precipitation. Slopes can affect the amount of runoff. Well, if we're talking about slopes, we're really talking about the shape of the land, and the technical name for that is going to be the relief. And we know that relief rainfall is one of our three types. And lastly, okay, interception, infiltration, occurrence overland flow, transpiration. This is all talking about the impact of vegetation. So they are your 5 physical factors affecting sort of physical factors affecting the flow of water in a drainage basin. Okay, so now we need to use and we need to have a look at an exam question. So what you've got here is an old exam question from the previous spec, but it's a really good one. So you have to forgive me for it being 10 marks. In your exam, it would actually be 12 marks. But it's such a good question for A, getting you to think about physical processes, and B, getting you to think about how to unpick this type of question that I've included it. Now, what you've got here is a figure. You've got area A and area B, and you're being asked to explain how physical factors influence water availability in areas A and B. Now, the first thing you need to do is you need to bug that question. And if you do that, you box explain and you'll underline physical factors, water availability, areas A and B. Now, the great thing about this question is that everything you need to know is in those diagrams. So let's have a look at how we can unpick this. So basically, to do this, what you need to do is you need to play spot the difference. I'm not quite sure what I've done with this. There we go. So first of all, look at area A and look at area B. And the first difference is that area A has substantially less water available per person than area B. And not only that, it's falling. Okay, so the amount of water is decreasing. It's not staying the same. So instantly, that's going to be your opening sentence, comparing the two. And then the way to do this is to annotate this diagram, spot the difference basically, and then each difference is going to be a sentence or two in your answer. So let's have a look at the next difference I can spot. Well, I've actually got the difference in temperature. One's 12 degrees, one's 25. Well, 25 degrees is going to cause a huge amount more evaporation than 12 degrees. So instantly I can see that the climate there, in terms of temperature, will reduce the amount of available water in area A because more of it's going to evaporate. Have a look then in the ground. Well, if we have a look, we can see that actually there's a large supply of groundwater in area B, but area A has got very little groundwater, and what groundwater there is fossil or ancient groundwater, i.e. that's water that's not been replenished. And that's probably the reason why the amount of water available is falling, because as that's used up, extracted, okay, or abstracted to use the correct word, then that isn't being replenished, the amount is going to reduce. Again, have a look and see if you can find another difference. This time, let's have a look at the actual vegetation in the soil. In one, we've got dense vegetation. That's going to increase the amount of interception. It's going to mean that there's greater green water stores. If you remember, that means water stored in vegetation. It's going to mean less overland flow. It's going to mean that the water is more likely to go into the soil, go into the ground. There's more likely to be more transpiration, which may also increase the precipitation. Whereas in area A, if we have a look, very little vegetation, so there won't be much in the way of interception. Thin soils, which means that the soil can store very little. It means there's probably going to be lots of overland flow, goes into rivers, it's going to be exposed to that hot temperature and it's going to evaporate. So again, we can see that that is going to be a major factor in explaining the change in access to water between the two. And then two more things. First of all, you've got rainfall, the amount of precipitation. Well, that's really obvious. If you've got 1800 millimeters of rain, you're going to be in a quite wet climate. 500 millimeters of rain is semi-desert. So again, the input here is going to impact the availability of water. And probably the last one, is to think about the rock type. You've got a porous permeable sandstone versus an impermeable granite. So that hopefully has helped you unpick the different bits. All you need to do then is write one paragraph about the amount of water, one paragraph about temperature, one about the annual rainfall, one about the vegetation, one about the soil, one about the rock type and the groundwater. And it doesn't even need to be a paragraph, 2 sentences for each one, making sure you're comparing how they're different and you're using technical words. The technical words you need are precipitation, evaporation, green water, blue water stores, infiltration, overland flow. You need to be using at least one of those in each sentence. And if you can do that, there's absolutely no reason why you cannot get to level 3. And to be honest, with this question, there's no reason why you can't get to 10 out of 10. So have a go at that and email it to me. Now, having done physical factors, you've got another bit of homework, and that's to look at human factors. So again, you've got this sheet in the worksheets I've sent you. Your job is to do some research, do some internet research, and have a look at 4 different ways in which humans affect the drainage basin and to fill that in. So that's coming to the end of the lesson, basically. We've looked at the physical and the human factors affecting drainage basins. You've got an exam question to do and you've got some research to do. That should keep you busy for the next week or so. So have a go at the 10-mark question, email it to me when you're ready. If you're not sure about anything, email me. And until next time, thanks so much and bye.